Hello everyone. Before we begin, if you can all please confirm that you can hear me and see the slides clearly by just typing yes in the chat window, please. Okay, thank you for the confirmation. Please feel free to introduce yourself, name, position, and company, and which country you're based in. It's always great to see an international audience of people from all industries and backgrounds. So nice to meet you all. First of all, I would like to thank you all for registering and taking time out on a Saturday to learn about wrench time data analysis, which itself shows that you're all high achievers and interested in expanding your technical knowledge. So we hope that by the end of this webinar, you'll have gained good knowledge about the subject matter. So as some of you may know, this is our 37th webinar in a series of technical webinars, as we are conducting one webinar every second Saturday. So please follow us on LinkedIn and make sure to check our website to stay tuned to the latest updates. So today's webinar will be most beneficial for mechanical reliability and operations engineers, team leaders, and professionals. So my name is Asin and I'm the commercial director at Velosi. We have quite an experienced panel of speakers here for you today. I'm here with my colleagues, Mr. Ijaz, Ms. Mubina, Mr. Wajahat, and Mr. Tony, who are experts in this field. So you're all in good hands today. So during this webinar, we encourage you all to keep asking questions to clear any doubts. This can not only help you, but also many others who can usually have similar doubts. So you can type your queries in the Q&A window, and you'll either receive a reply in the window or live if you feel it's something that will benefit everyone. So we'll try to answer questions at the end of each section. Please make sure to ask your queries in the Q&A window and not in the chat window. And we will also have a detailed Q&A session after the completion of the topic if time permits. Please accept our apologies if your question is not addressed. Due to the high volume of questions we usually receive, we have to be quite selective. We will also be issuing participation certificates to all those who have attended at least 80% of the webinar and have participated in the discussions through the Q&A. So those who are registered with PEC, Pakistan Engineering Council, they're also eligible to claim 0.5 CPT points through our webinars. So after you've attended the webinar, please send us an email on the mentioned email address. Once your attendance is confirmed, we will be issuing a separate certificate mentioning the points that you have earned, which you can further submit to PEC. So please write us an email at cpdclaim@velosiaims.com once you've attended the webinar. So before we begin, although most of us are in the comforts of our home, we should be aware of all emergency exits. Due to the current COVID-19 situation, we should keep a safe distance and in general take care of ourselves and of those around us. So the agenda for today, since this is quite a technical subject, as we will be touching key theoretical and practical aspects of wrench time data analysis in this limited time of 2 hours. So we request you all to follow along with us and keep asking questions to help us in making this as engaging as possible. So today's webinar is based on a case study that we have conducted previously. Please note that the client name and data have been redacted. We will be following a practical approach where we will walk you through the key steps through this case study. As you can see, we'll be covering the introduction, the approach, the project summary, results and outcome, assumptions, conclusions, benchmark references, and then followed by Q&A. So the main goal is that by the end of this webinar, you'll have gained a good idea about the objectives, methodology, results, and the significance of wrench time studies. So I'll start by quickly giving a brief introduction about Velosi and what we do. So Velosi is a leading global consulting firm that provides asset integrity management, HSE, engineering, environmental, and software solutions to clients in the oil and gas, energy, power, and petrochemical industries around the world. We also have our in-house proprietary software, Plant, which is an industry-leading certified SAP certified complete asset integrity solution, currently being used by oil and gas giants in the region, such as ADNOC, Dragon Oil, TANUP, and more. So the group was founded in 1982, and since then we have expanded our footprint to more than 38 countries worldwide, offering a full range of specialized consulting services tailored to the energy industry needs. Here's a map showing our worldwide existence. So by combining global coverage and local knowledge with our wide range of services, we are able to create tailored solutions to complex problems. So our range of interrelated services and integrated approach ensures that we can accommodate a wide range of complex projects. So the services we provide cover a broad range of industries and facilities, such as oil refineries, GUSPs, gas and NGL plants, chemical plants, fertilizer plants, pipelines, offshore platforms, wellheads, structures, and more. So let's jump into the services that we provide. So we are industry leaders in asset integrity, specifically for RBI, PIMS, pipeline integrity, structural integrity, pressurized equipment management systems, inspection scheduling management system, wellhead integrity, asset performance management system, computerized maintenance management system, safety integrity level SIL, RCM, reliability centered maintenance, RAM, reliability, availability, maintainability, condition-based monitoring, condition assessment studies, asset life extension studies, corrosion management planning, corrosion risk assessment studies, DCVG and SIP surveys, and technical trainings. We also provide HSE services. We carry out the complete scope of HSEIA studies, health, safety, environmental impact assessment studies, process safety and risk studies, workshop facilitation, risk assessment, safety cases, health, safety, and environmental critical equipment systems, drilling HSE consultancy services. We also carry out environmental studies covering the complete scope, such as the impact assessments, management planning, compliance auditing, modeling, monitoring, and testing with our in-house equipment. We also provide occupational health risk assessment studies covering both qualitative and quantitative. Occupational health risk assessment, emergency management and planning, workplace exposure monitoring, and industrial hygiene monitoring plans. Moving on to engineering, we carry out conceptual design feed, detailed design and engineering consultancy services. We develop operating manuals and procedures, carry out design verification and appraisal, fitness for service, as-built drafting services, and PMC services. We also have our in-house team of software engineers where we're always developing new innovative solutions. So over the years, we have developed multiple industry accepted solutions such as Whale Plant, which I mentioned earlier, Complete Asset Integrity Management System, Whale PHA, Process Hazard Analysis Software, Whale PSRA, Petrol Station Risk Assessment, Whale MTS, Material Tracking System, Whale ERP, Enterprise Resource Planning Software, Whale CTR, Cost, Time and Resource Management, Whale CMMS, Computerized Maintenance Management Systems, Whale Flow, Document Approval Workflow Management System, ORP, an online reporting portal, CRM, a Customer Relationship Management System, and then Whale Feedback. Then we also conduct various technical audits and assessments, such as the OSHA safety audits, technical audits, environmental, process safety management, structural, firefighting system adequacy, regulatory compliance, flammable storage facility, and electrical audits. Last but not least, we also provide ISO consultancy and training services for ISO 9001, 14001, 18001, as you can see here, covering occupational, health and risk safety management and energy management systems, asset management systems, and quality management systems. So Velosi has successfully executed over 600 projects with over 300 clients, including ADNOC, Dragon Oil, Saudi Aramco, Petronas, Dolphin Energy, KPOC, and many, many more, as you can see here. So here are some of our certifications. Here are some of our accreditations and approvals. And here are some of our memberships. So now I'll hand it over to Mr. Ijaz, who will start with today's topic.
Assalamu alaikum and good day everyone. I know somewhere it's morning and somewhere it's evening or night since this is a global event. Coming back to the topic, wrench time is a subject very close to my heart, being director of the company. And wrench time is very important for us as a management personnel to ensure that we have better efficiency from our manforce. Whether we are working in an engineering office, whether we are working in a workshop, or we are managing operations, or we are managing maintenance tasks or inspection tasks, wrench time concept is very important for us to remember. Now, as a definition point of view, what is wrench time? Wrench time is a measure of the time a maintenance craft worker spends applying physical effort or troubleshooting in the accomplishment of assigned work. Now, if we try to see the same thing in our student point of view, let's say, for our children or for ourselves, like how much is the effective study time for a student? Like at home, let's say it's easy to monitor at home. At school, different aspect because there are various periods and various teachers are basically arranging those classes. However, when your child is coming home, at that time you have to see at what time he comes back. When he takes his lunch, then he sleeps, then wake up, then he goes for a game, or he start playing his maybe uh, PS games or other games, and then he try to go for dinner and then try to study, and then between the TV drama and so on, and then sleeps. Uh, in practice, you may feel his effective study time, which could be a range time for the student, is hardly 2 hours or less, or maybe 3 hours. But available man hours for the student could be from, let's say, 3 p.m. to 10 p.m. before sleep time, 7 hours. Out of those 7 hours, a student might be spending less time on the actual study. Similarly, let's see an office working environment where offices all the staff is arriving, let's say 9 a.m. in the morning, and then they go back, let's say 6 p.m. Effectively, they got 8 hours, but how much is the effective time they are working? When they are reaching to office, they may go to washroom, they may go to tea or coffee, then come back, and they might seeing their personal emails or personal messages, and they may chat to their friends or their unofficial calls, and then they would be starting the work, and then they will go again a tea break, then come back, and they might be chatting with the other colleague for another political issue or some other social issue or any other incident happened in the world. And then they will start doing the work, and then there will be lunch time. After lunchtime, even though they're supposed to offer their prayer between the lunch times, they may offer prayer after lunchtime, and then again they may start looking at their emails, personal messages or personal home tasks, and then they go back to work, and then there's a tea break again, 3 to 4 hours, like 3 to 4 o'clock, and then they would be working somehow. And if you see that, you will not find effective working hours more than 80%. 20% time in the day would be spent by the workforce in non-effective activities or non-official activities even. Similarly, if you see a yearly time, normally we feel we work 1 year, 12 months, but there's a 1 month is a vacation period. And then if you see another one, another 15 days could be a national holidays which are applied by the government of that country. And then there would be another sick leaves which people can take, and if you add those sick leaves, then there would be these days taking off by the national holidays, and then the time taken by the annual vacation. So practically 2 months are not basically being worked out as a effective time, and 10 months out of 12 months people are working. And then you take it to a day wise, this is the case, and then there are weekend off days. So in this way, it's very important for management people to see how much effective work is being done by the man force actually doing the job. And in natural, like sorry, in general aspects, if you apply this concept on the maintenance department itself, if you see the top quartile 50% and above, second quartile 40 to 50%, third quartile 30 to 40%, and fourth one is less than 30%. If you will see the reality, the many companies are operating between 30 to 40%, even less than 30%. This is one of the bitter, basically, reality of the workman force. So, what's the challenge? How we can increase from 30% to effective 60 to 80%. This is the challenge. And whether it is achievable, we'll see in the presentation. History point of view, as I explained to you various examples in our daily life, from students to the normal office workforce, and then we apply the same concept on the maintenance side. Like in the normal maintenance activities, if you see the plan is given for the maintenance of the maintenance crew, and then you will see that spares may be available, spare may not be available, or spare might be taken from the warehouse, and if you go to warehouse, the time is taken in the warehouse, basically how much, 2 hours, 3 hours when the spares are provided, then the work permit has to be taken from the operations, and then people would go to the work site, then they have to barricade it and get ready, and then there's a lunch time, and then go back, and so and so. So you will find that effective work time which is spent by the technician on corrective maintenance or planned maintenance could be quite less. So history point of view, time motion studies have been utilized for optimization and increase in productivity since the early days of industrialization. Originally, two studies, time study and the motion study, were utilized independently, but for later on combined to get a better picture of overall performance, it was made as a time motion or range study. Main idea behind the range time study, time motion, is to capture time taken by skilled craft worker to complete a certain task, provided all provisions and requisites are available, and then compare it with similar tasks performed by different personnel. The initial value is taken as a benchmark and used for all future comparisons. This is the history. Objective, as I explained, the main objective of range time study is to make sure we have more effective working. Like if we can ensure that, like a normal common saying, if the time which is being spent in waiting of the spares could be reduced, time which is being spent in waiting, receiving the work permit could be reduced. Number three, and if few activities could be done in parallel, for example, the time when people are taking the spares, people are taking the work permit, the barricading of the activities could be done. Then like the reference checking, like OEM manual checking and the craft skill checking and their availability on the field could be made more effectively. So the general objective for range time studies to identify non-productive time elements, to verify effectiveness of maintenance planning, to establish a baseline which can be compared with the benchmark as per best industrial practices, to identify the maintenance activities in need of optimization. Like one thing I would like to explain again and again, the range time is being focused on the maintenance because there is a time where technicians are actually working on the maintenance of the machines. That's why the range concept is coming. However, the time and motion concept or range concept, as explained earlier, can be applied on all the nature of activities in the plant. For example, let's see the example of an inspection department. Sometime we got NDT technicians, but they might be waiting for the erection of scaffolding, and the scaffolding could be delayed, and the NDT crew is sitting and doing nothing. Similarly, sometimes everything is there, but they are not given permission by the operation department to start their activities. So, by having a focus on these three things together, there could be better effective results from the inspection teams in the inspection department as well. So the concept, it can be applied on the engineering, it could be applied on inspection, it can also be applied on the maintenance. However, this study is focused on maintenance department effectiveness. So there are benefits and limitations, both are there. See, it provides opportunities to increase productivity by qualifying and quantifying the activities of maintenance craft workers. However, it should be remembered, it does not provide feedback on quality of work. It helps to verify the value for paid maintenance services. No industry average point of view, you see that. Maintenance staff productivity level Industry average is 35%. The best companies greater than 52%. Still, if you, there 48% gap is still there in the best companies as well. The total man-hour charged to work orders as a percentage of maintenance execution staff 80% and greater than 95% annually. Rework, this is also issue like if the maintenance is done in a hurry and may be done like in a improper way, then there could be a rework. In average industry, 10%, around 10% man hours are being spent on the rework, whereas in good companies, 3%. Mean time to repair of the failure data, equipment specific, this could be equipment specific, but like it varies from one company to another company, like how much time is being taken by the staff for the repair activity of a particular machine. So again, during the course of execution of the wrench time study, more focus could be given to the following factors. There are many factors, like let's see, example point of view. Categories that are biggest distractors from active repair time, need for development of focused improvement plan, BOM improvement, reducing time to LOTO or work permit system, improve communication of assignments, improve operation maintenance coordination, focus job plan improvement recommendations, including availability of the spares, tools, instructions, equipment condition, mobile equipment assignment, for example, lifting equipment or forklifter, they might not be available. Need for standardized maintenance practices among different units that may also help to increase the basically effectiveness of the maintenance activities. See, there are also like wrench time do's and don'ts. Like when we are doing wrench time study, the purpose and objective should be clear, and otherwise it can confuse between the wrench time and the effectiveness of the maintenance activities itself. The main reason for conducting a wrench time study is to identify non-productive activities that are causing delay in maintenance activities, to identify the interdisciplinary communication gaps, use data to drive improvement, not to assign blame. This is very important. However, the balance has to be there. And if like somewhere time is being lapsed or being wasted by certain crew members, certain time leaders, team leaders, so there would be like a certain blame. However, we try to convey the message it's a gap assessment rather than putting the blame on the people. So there are cautions as well. Like wrench time studies are not about finding personnel who are inefficient, making mistakes, or performing poorly. Indirectly, you may say so, but message goes there somehow, and we cannot hide these things. And though we say during the wrench time study, as it is stated, we are not like trying to find personnel, but if somebody is taking more time as compared to other team member, so it would be identified. And if there is a more rework of a maintenance by certain crew or certain technician versus others, so it will also take to the performance evaluation. So somehow it should be minimized, but the issue would remain there. Wrench time studies are about the quality of the planning and scheduling process and how effective the organization execute the both processes. So it's the planning, scheduling, and execution as well. Crew should be ensured that the study will only be used to drive positive improvement, like when we are doing wrench time study at that time. But if indirectly, when people are being monitored by the wrench time team, wrench time monitoring team, the caution would be there with the people who are being monitored by the wrench time team. So somehow, whatever we say, there would be certain response or certain reaction or certain caution by the teams. Like improvement point of view, how it can improve. Like if we try to find out various like aspects which can help to reduce the time which is being spent. Let's say the first thing is availability of the spares. It could be made available or made available before time. Number two, work permit system that could be done. Number three, mobilization of the staff, whether like what kind of transport is being used, or they're using cycle or they're walking. Then availability of the equipment from the operation site in terms of barricading and so on. So if you on the same points, if I try to go by the structured way, reduce the time to do maintenance, reliability of the equipment, MTBF can be improved. Improve the effectiveness of resources need to perform maintenance, people, tool, and contractor. This is where range time analysis comes into play. A single change cannot effectively improve range time. Rather, a complex series of optimizations is required to improve the range time, not a single factor. For example, improve material coordination, improve planning, improve scheduling, increase field supervision, optimize travel maintenance KPIs. Then small improvement efforts, usually done on small specific areas by a cross discipline team, can last a couple of hours for a few days each event. Focus on making small improvements in a systematic way can create large results in a continuously exercise actions. Aim to promote zero losses through waste, identifying and correcting problem with flow, improve the effective use of assets, reduce manufacturing cost or maintenance activity itself. Or approach, since we are presenting a case of actual range study what we performed for a oil and gas operating company, we're not disclosing the name since it correlates the data. So there are two parts. So I would be presenting up to approach, and then my colleague, Mr. Wajahat Malik, would be presenting the actual results from the field, since he was the project manager at field at that time when we executed this job. So general steps, what we normally do: data collection, a review of policies, strategies, and maintenance management system, resource verification, classification of activities, resource coding, work sampling and work order selection, field observations and data capture, work sampling calculations, detailed data evaluation and analysis, report and results. Then we make the observations and improvement recommendations. So same steps basically are shown in the flow pattern, and this would be my last slide, and then we take the questions at this stage, and then there would be next take up would be by my colleague Mr. Wajahat Malik. So here the same thing: data collection, which is PMR, BOM, task list, then initial review of the current strategy and assessment of data within CMS, then PMR associated BOMs and resource planning verification, then categorization of the various classification activities, then resource coding, work sampling, then collection of observation data, field observations, the work sample calculations, then data evaluation and analysis, then overall result and analysis reports, and then observation and improvement recommendations are given in terms of the basically report. So next is basically now we are presenting actual whatever our actual activities were done for this particular project or case study what we are presenting today, and I will now invite my colleague Mr. Wajahat Malik to start from this slide. But before that, Asen, if there are some questions we can answer now.
Yes, there are a few questions. So one question is, what's the average drench time in percentage terms for a refinery maintenance works? Let's say a shutdown maintenance for a period of 1 month.
No, we did the study for the normal routine corrective and preventive maintenance activities, and this average time was between 30 to 35%. Shutdown we did not check.
So this is the time that's spent on the actual activity.
Yes.
Is any software being used in this industry to carry out this activity?
No, see, this is observation. You need to monitor all staff which is working or who is working on the particular unit, and you have to monitor all actions per technician or supervising team. There is no software. Excel spreadsheets are used.
And how long does such a project take to execute?
We took almost 2 months to make our observations, and third month was used for reporting. 3 months.
And then what's the optimum method of measuring the range time? The main criteria among the array of parameters.
So that will be presenting the next slides. Yeah. So you have to hand over the charge to Asim, to Wajahat Malik now.
Yeah, 1 minute. Now, what should be the ideal correlation time between reactive maintenance and predictive maintenance for any activity?
See, both activities are separate. The planned activities basically are done as per the CMS routines, if those are being done. Otherwise, the corrective actions are as per the call outs given by operations, and if there is any equipment is down or showing some problems. So those both activities has to be taken separately.
And some of them are also asking about benchmarks, which we will cover towards the end of the
Yes,
presentation, right?
benchmarking is there. We gave also in the beginning the various the best quartile and the lowest one. We have presented both the best companies and the average companies data. That is there in the first slide. If you see this, like we started with this, like in the first slide,
Okay.
the average like 50 and above, then the lower one are the 30%, lesser than 30%. This data is provided.
Is MTTR the same as wrench time?
No, MTTR is the mean time to repair, the time which is being taken to do any particular activity. For example, if a machine is down or major overhaul, how much time is being taken on that activity? That is MTTR.
And does this wrench time improve the MTBF?
See, MTBF is mean time between failures, right? If a machine is failing, like one after another, like time period, so average time or average number of failures every year or every 5 years is called MTBF. Range time is the basically effective time taken by technicians to correct on the machine, to correct the machine functions. There is range time. Like in normal sense, like how much time a student is practically studying a book. That is the range time for a student. For an engineer, how much time he's taking to make the drawing or calculations, rather than, as I said earlier, he's coming to office and then he is spending time on tea, coffee, chat, other things. Those time has to be taken out.
Okay, so now I will hand it over to you, Mr. Wajahat. Um, are you able to hear us, Wajahat?
Yes, Assalamu alaikum, Mr. Hassan. I can hear you. Thank you
Yeah,
very much,
okay.
Yasin.
We will stop sharing the screen and you'll share it from your side, right?
Okay.
Then we'll have us basically answer questions, another session at the end of this basically presentation.
So Wajahat, you can share your screen now.
So can you let me know if everybody can see this screen?
Yes, we can see it now.
Thank you very much.
Yes.
Thank you, Justin. Just like Sarjaz mentioned, that there are some steps involved when you're performing wrench time, because I can see that most of the questions we are now getting are related to how the wrench time should be performed or if there is any standard template. Before I get into it, there's one thing that need to be cleared out. People are relating wrench time with the MTBF. See, when it comes to maintenance cost, basically everything that is being done to optimize the maintenance cost. Maintenance cost, you have two major factors. You have your mean time between failure and you have the mean time to repair. Bench time is a technique that is required or that is utilized to optimize the mean time to repair. So it is an optimization technique for MTTR. MTTR does not depend on the bench time itself. The second thing is standard templates or the industry averages. Standard templates, there are guidelines present in different reliability documents, in different reliability, what you can say, reference material for bench time, how to perform it, but there is no specific template for it. So it has to be customized for each client. It has to be customized for each industry and each situation. Shutdown situations are different. There is no permit requirement. There is no LOTO requirement, etc. Whereas in a live plant, you have to go through all those steps. So the standard or the templates, they have to be customized. The averages are taken for the industry and they are applicable under any condition or any situation. Now, coming to the preceding summary, So Jaz has very well explained what range time is, how it is effectively helping in improving the maintenance optimization programs across the world. But to perform the range time itself, what we need is we need to understand that the range time is two-factor concept. One is the culture that needs to be improved. The other one is the system that needs to be improved. Before you can get into the range time optimization, the first step has to be the system itself. So what we do is, as the first part, you need to know whether there is any scheduling going on or any scheduling being performed for the maintenance itself, whether there are plans available for the technicians or the skilled craft to use, whether or not the guidelines or the task lists are present, resources are there, is there any identification of what material or what UM or what part number needs to be used under a certain condition for a particular equipment, or any documentation that, for example, for electrical, if there are single line diagrams even available for the skilled craft to use during maintenance. All these are the first part of the main picture, or as we call them, the step one. In the second part, we perform an initial review of the system itself, whether when you are issuing a maintenance plan or for a particular equipment, does that equipment actually exist anymore? Because what we have seen over a period of time, that once the asset has been installed, nobody bothers what happens to it in future, whether it has been replaced with a different system, it still exists in the CMS system, and the work orders are still being generated. So what that means is that the CMS system review is the second step that should be done to identify any gaps within the effective range time before the actual observations are made. So in the second step, what we did, we actually evaluated their existing system, whether they had the markup drawings, whether they had their complete task list, whether any history was available to understand that a particular equipment requires maintenance so frequently and what kind of time it was taking, why it was taking longer than the other equipment. Right. Uh, After that, resource planning verification. What we did was we categorized. If I can go back a little bit, Sarjas defined here that in our approach we categorize different resources, different crafts. We categorize the time domain into certain small factors, so it can be analyzed, so it can be recorded in a matter that can later on be analyzed through any software. You want to do it in Excel, there are other tools available, different tools available. So first, the data needs to be categorized into certain steps, like the manpower, it need to be coded. There was some resource coding performed here. Work sampling was done. What kind of work orders should be observed? We had to ensure that this study included different type of work orders. So the result is not very, what you can say, overwhelmed by a certain type of work only. For example, if we look into a workshop situation, in workshop the part is available, the spare parts are available, the equipment under investigation or maintenance is available. There is no hurdle, there is no support required from other disciplines. Therefore, the wrench time value will certainly be different on the same equipment itself. But if some certain task has to be performed on that particular equipment while it is in field, then there were many different factors contributing to a lack of range time. So for that purpose, we performed a work sampling. Work orders were selected very carefully. And after that, the observations were made on time frame basis. Right. Now, back to these were the categories that we divided the time into. Productive time, that is pre-post job cleanup of the job site itself, the work travel, and the actual performing of the work. Then there was no non-productive time, for example, lunch breaks, idle sitting, training. See, training itself is considered as a wrench time if it is a part of a training program, but when it is being done on the go, then it is not exactly wrench time. And there were other non-productive times, for example, where actually the time is being wasted. When we come to the results, we will actually get to know that this non-productive time is not the biggest contributor to the problem. The biggest contributor was the material is not available, tools are not available, the clearance to perform the job was not available, the job assignments, they actually take certain time in between, which is not if not properly planned, is actually the biggest contributor to the loss of bench time. Waiting for other disciplines, just like Sarjas mentioned, scaffolding was not present, verification was not done, some other support required from a different discipline. For example, if an electrical motor had to be dismantled, mechanical support was not provided within time. So all of those things, they are the biggest contributors to the waste time or the non-rent. These were the some categories that we identified. Now, how this study was performed was for a day or so, we observed what the team actually does at site. So after the observation, then we decided some categories that need to be established before the observation can be made. For working itself, we decided that if somebody is actually performing work, there were some small abbreviated terminologies, obviously, the description or the detailed definition that was mentioned separately. But in abbreviated form, if somebody is actually working, is traveling for work, there's a setup or a takedown approach being happening, work assignment is being done, wrap up, etc. So we considered that the person was working. Miscellaneous was defined. It is waiting for something that was also defined. Resource coding was done to make sure that the data can later be verified. This resource coding is not a requirement to establish the average range time, but it is a requirement to ensure that the data captured is actually correct and can be verified against any existing CMS job assignment task. For example, if we are observing for an electrical technician, we will have a resource code against which the time was observed, just to make sure that a work order was issued on the same date and there is no gap. The observer itself has not made a mistake, or it cannot be challenged in future that a particular technician was not actually performing the job. So for that purpose, the resource coding was done. Designation is the same. Basically, this is where the names come. This is where the designation comes, but it's the same concept. This somebody asked like what kind of sheets or what kind of templates do you use. As I said that these templates had to be customized for each situation. This is one very basic template that we can use for such a purpose. Example is very simple. You define a time frame, like within the time frame, obviously in 1 hour you have 60 minutes, so within that 60 minutes you have to make some brackets, suitable brackets of 5 minutes, because if the time frame is less than 5 minutes, you have to round it up to something. Otherwise, you will have indefinite values to interpret and etc. Within the time frame, then you make observation categories. These observation categories are actually based on what we just described, like whether he was working, whether he was resting, whether he was getting instructions, then the work order number, then the observation date, day of week, supervisor who we were reporting to, and the observed time. These comments were actually for internal use only. They can be detailed because one of the major issue when capturing a range time or performing a range time study is that the observer has to be well versed with the type of craft which is being performed. A electrical discipline observer can only is only recommended to observe a guy who is performing an electrical maintenance task. Reason being that us or the maintenance teams are very intelligent in pretending to work, and not everybody can guess whether it is actually work or whether he's just fooling around with it. So we left a box for comments where the observer was actually making exact comments what his actual observation of the task was, because there is one thing claimed work and there is one thing actually observed work. So for that purpose, we leave a box that is called internal comments. These are the time frames that I mentioned. When I say that we divide it to time blocks, because within 15 minutes, a guy can perform three sets of a 5 minute task. If he is performing complete 15 minutes of work, it is perfectly fine. But this gives us a margin that multiple activities can be performed within a 15 minutes of time. 15 minutes, 5 minutes. So this is how it was broken down. Observation is made as soon as the craft worker enters the plant. That is, let's say if the plant shift starts at 7:45 and he leaves at around 4:30. So within this time frame, we divide it into certain periods. Within these periods, the observations are then made. The other mentioned observations here or the categories are the same as we already discussed. The data includes the employee identification, craft supervisor, work category, unit status, uh, date, day of week, day of hour, plus the comments regarding the certain individual. This is, I mean, the comments from the observer. Now, this data, it is collected data has been observed as a complete maintenance stay, just like I explained before, on an accumulated basis. The time machine observations were made for scheduled and present workforce. This is the reason why we need to do a resource coding of manpower itself. Because if the observation is being made, it should be verifiable, and the attendance of that particular craft has to be ensured in the system as well. So, for future cross checking or for during analysis of data to ensure that the data is correct, these observations are made for the present purpose only. Temporary non-working periods, you can also include them or exclude them as per the requirement, but that will give you some unrealistic data. Then the data collected using proposed methodology has been analyzed. Okay, there's a short example. Okay, the example basically says that if a craft worker enters 7:45 in the morning, leaves 4:30, basically he has 525 minutes that he can perform his task, whatever has been assigned to him. Within this, there are two breaks. One is a lunch break, and then there's a 3 minute tea break. This is for a particular case. It can vary from case to case only. So within those 525 minutes, we will subtract these 45 minutes. We are left with 475 minutes, which is actually where he is supposed to be working. This is one example sheet. It's the same sheet that we just discussed before. Here, if you see that most of the time he worked for 20 minutes, for 20 minutes he had to wait, 15 minutes he was traveling around, 15 minutes another he was traveling around, then he was waiting for operation to give him clearance, etc. etc. Practically, he was working for 20 plus 5 minutes. The wrench time or his actual productive time out of this 85 minutes was only 29%. This is how it is calculated. Productive time divided by the total time and then the percentage. When you say productive time, it is based on the categories that we already selected, that these are the categories that we are going to count as wrench, and these are the categories we are going to count as secondary categories. You can, if you want, you can include them as rent. If you want, practically what the practice is, I mean, from the reliability literature, the practice is that the secondary or the associated activities are considered as support activities, not necessarily rent time itself. Now, as an outcome, this is something that we got. The 22 categories that were identified or that we just described above were identified that in total working was around 33% for a particular unit or a particular plant only. Then about 8% he was traveling for work. 15% he was waiting for task assignment. And interestingly, you see that he had to wait about 7% of the time just to get permits for it. Basically, 2.9, that is almost 3%, then 7%, 10%, plus 15%, clear 25% of the time, effective maintenance time, is being wasted by an activity that can be handled by the planning department in a better way to avoid the wastage. There are other factors also. People do take personal time, no doubt about that. They were also observed to be totally idle. There were also isolations involved. Operation department delays there. But the major contributors, surprisingly, were the planning themselves. I mean, operation planning and the maintenance supervisor coordination was the actual source of delay. Because if he's waiting for the instructions, that is from his supervisor, waiting for the permit, that is operations. If the work is not assigned to him, again, the supervisor and the maintenance planner, 25% of the time was wasted here. Now, surprisingly, this does not change when you go across the discipline. It is generally believed that some disciplines are more effective in performing, whereas other disciplines are not so efficient. But when we made these observations, uh, it turned out that among the disciplines, the culture stays more or less the same. Yes, among the plants, among the facilities, it does change. But within the discipline of the same facility or of the same plant, it was more or less the same finding everywhere. If one of them is lagging, the other one is performing more or less the same thing as well. There was a very small difference between all three disciplines. Okay, this is another presentation. Since this was done for a petrochemical plant, so there's some of the arbitrary area names are also appearing here. So uh, within the different units, you can see that within the different units or within the different plants, the values do change. But within the discipline, they were kind of within the same ballpark figure. However, this tells us that some plants or some cultures do handle their stuff, their planning, their maintenance in a better way as compared to others. So it's not always the performer or the craft technician who is the reason for this, what you can say, less range time or wastage of useful man hours. It can be other factors also. This is same thing is done for another discipline, then another discipline, etc. So on and so forth. Overall, for a complete facility, in 24,000 minutes captured, 37% was the observed bench time, 7% they were traveling. Assignment has come down for from 15 to 11% now because, as I just showed, that some of the plants are managing it quite well. Same, if we look at the permit delays, they are still standing at 3%. Instruction has decreased again because of the better performers. Isolation, here it shows zero point 0.3, but it was practically in the individual plants, it was much more than that. Yes, since workshops were also included, therefore the isolation delay has reduced a lot here, and so on and so forth. Other than that, if you see idling, break, personal breaks, about 20% is wasted there. This has to be improved through the culture. This has to be improved through the system. There were two main contributors, the system itself and the maintenance culture that we both need to be looked into for implementing them. Right. Now, for evaluation, from evaluation point of view, just like I showed you that each category of each craft has to be captured throughout the day or throughout the predefined period of time. Within that, what we do is we can capture the overall range time, we can capture the discipline specific, we can capture the plant specific, you can also do it for the contract hire, like somebody was asking about the shutdown situation. So yeah, that can also be done within this with the same methodology. Then the total time that you have captured, the more time you capture, the better results or better picture you will get. Because the first day when you start doing this thing, then everybody is very uptight and everybody is very efficiently performing their job. By the third day, they realize that these guys are here to stay, so they go back to their normal routine. And the last interesting point is time of day specific trench time. This will come to you in a while. We actually performed the detailed data analysis of different units. Analysis was performed using best industrial practices and margin of error was used as 95%. I'll come to it how it was done. Collected data was observed as a complete maintenance state, like when they enter and when they leave the plant. Special care was taken to ensure that the margin should be kept as minimum. Therefore, a 5-minute bracket was used to round off the next possible. This is a very good pie chart that shows what overall we observed during this whole project during this whole study period, people were actually spending 34% of their time in working, 14% waiting to be assigned with something to do, 6% waiting to be allowed to do something. There was also work travel involved because this was a huge facility, but work travel again is something that can be optimized. It cannot be removed definitely, but it can be optimized in a better way. Use this one. Effectively, you can gain 14 plus 6. Then there is operations delay 4%. Break should be optimized. 11% was not, intended to be the break time they are taking. So again, the culture needs to be improved. Effectively, you see that this 34 plus the major losses that we can see here added together is approximately 20%. From 34, they can jump to 64 by just improving three major factors. Yes, this is the graph I was referring to that time of day surprisingly had a very interesting effect on Gen's time. This is where the culture comes into play. In the morning, there's a huge red chart. The red is basically where they were not getting permit to perform anything. Slowly, this decreases by about 9 o'clock. Everybody is working more or less. Then there's a tea break, just like Mr. Jaz mentioned, that it's a cyclic uh, time frame that repeats every day. From the tea break, some people were still taking a tea break after an hour, whereas others went back to work, so on and so forth. But throughout the day, you can observe that there are factors that are system dependent. There are factors that are culture dependent. There are big chunks of breaks that are not actually scheduled breaks. This is what we call flexi breaks. They sound good that anybody can take a break when they want, but end of the day, it does not help. Reason being because as a culture, it kind of provides a flexibility to spend more time than you're actually allowed. So then by the end of the day, you can see that there's a big dark blue appearing. Dark blue was actually the work assignment category. So as the day progresses, people have finished their work and the supervisor was not able to provide them with more work. This was observed under a situation where there was about a 7% backlog per week happening. They were under backlog and still the task could not be assigned. Reason when it was observed or when the root cause was performed, why this is so is because when people come to work, they try to pick and choose what they want to do. They tend to go for the smallest thing to do in the first half of the day or in the early part. College. Okay, so when they come in the morning, they tend to choose the smallest work that they can do. Reason was because there was a tea break. So before the tea break, they perform that task, they can come and relax. Then they tend to go for the bigger task in the middle of the day. So by the end of the day, the small tasks are finished, the big ones are left. The big ones cannot be assigned here because they had to close it within the same day. So the task gets carried on to the second or the preceding day. This is where the backlog was coming from. This is where the system and culture both needs to work together. That start of the day should be started or planned in a way that the major chunk of the work needs to be done in the first thing in the morning. So you have the small tasks that can be distributed in the last 30 or 15 minutes. Even if you don't have anything, you can use this time for wrap up. People were actually performing wrap up somewhere around here. So the last 1.5 hours was complete waste of time technically. Okay, overall result. I mean, best in class value. Because somebody was asking benchmarks. There are benchmarks. We will go to it by the end of this presentation. There are some benchmarks. Some of them are by Dr. Palmer, the reliability expert. Some of them are by other reliability literature. Maintenance Excellence Institute, they issue some benchmarks for Einstein. Similarly, there are other studies performed by other consultants, some giants like DNV, they have performed this. They have their own benchmarks that are published. So generally for oil and energy sector, it is set to be between 45 to 55%. And this target value is said to be a decent value. It needs a lot of working. Sounds very sounds very easy that okay, I only have to work for 50% of the time, but this 50% of the time is not that easy to get. Then the extensive use of predictive technologies. As I said, that you need to know what big tasks you will be getting soon. Because if you're going to work in a reactive environment, you're going to wait till the last moment. Oh, now the bearing has gone, so you need to replace it tomorrow. That tomorrow is going to be a big waste of time for you. If you knew it well before, the planner or the scheduler can put it at the proper time in appropriate with some appropriate resources with appropriate material, and then that will be more effective to perform the task, the same task, and it could be done in a better way with much less. In a reactive condition, you can hardly achieve up to 35%. This is also the free what you can say the value. And just like I was mentioning that during the course of the project, the major improvement that was seen was isolation and permits, especially at the start of the day. Big time waste, material coordination. It was observed that this was also contributing towards a huge waste of time. The best practices. This is where the best practices come into play. That material kitting, a new phenomena of maintenance optimization nowadays. We have a maintenance optimization program, which include something called spare part optimization and material kitting plans. Kitting basically means is that with your PM plan, you should have the material kit also available with it. The bill of material is attached already to the all the modern job plans with most of the new robust organizations. But that material should be kitted by the storeroom or by the material department based on the work schedule that has been issued by the maintenance schedule. They should not be waiting for the maintenance department to raise the request for it. So the material kitting or material coordination can help a lot with this field supervision and coordination between the crew and the supervisors. Again, just like any industry, is a must for maintenance as well. Because if nobody is looking, then nobody is working as well. Time needs to be optimized, just like you mentioned that this was approximately 8% of the effective time that is being wasted in this travel. It is must. It is I mean, this is a must level that we must face, but it has to be optimized. The progress, the coordination that can help improve the planning and scheduling. Now, this was another interesting thing. If a maintenance team finds a flaw or a shortcoming within the plan, they will not generally bother to inform the scheduler because if they do, or the planner, because if they do, next time he will fix it. And if he fixes it, then they have to perform it. One example was that we noticed that some of the work orders were issued and then closed while on the coffee table. We were surprised that how can such equipment be running in a run to failure situation. When we investigated, we asked them for the drawing, we asked them for the layout. We investigated the equipment was actually demolished a few years back. But since the planning and scheduling department does not get a readily updates from the maintenance or does not get the feedback, therefore they were still allocating man hours for that particular purpose. Those man hours were being used by the maintenance team for the reactive maintenance they had to do for the backlog they had created in the past or something like that. So the progress measurement and coordination between the supervisors as well as the schedulers and the planners is not to have a robust, but to have a fair system. There are some more observations, we can go through them one by one. It has been observed that the material management and movement takes a significant part of the day, just like we discussed. It was recommended that material kitting should be performed where the store should be in charge. Now, this is not applicable for most of the corrective maintenance jobs, understandable. For preventive maintenance jobs, renewal jobs, this can be done quite easily, not a big size for it. For approval, again, there was an issue that they had a document-based system as well as they had a computerized system. So having a duplicate system is again a double waste of the same thing because getting two approvals from the same person is basically wasting his time and wasting the maintenance. So it was also recommended they should be using the online system. They had very nice online system with everybody has access to it. When the supervisors had portable devices where they could get their approvals easily. So it was recommended that online system is used for this purpose. Quality and methodology of maintenance work varies from area to area. This was actually the case where I was saying that from plant to plant, the effective maintenance time was varying, or what we call it as MTTR was varying from one plant to another plant. When we investigated why this was the case, was because that every supervisor had their own task list to be performed to ensure that the equipment is maintained properly. There was not a unified task list. The job plans were there for all the plants, but the task lists were supervisor specific. Each supervisor had his own expert input into the task. So it is highly recommended that throughout the facility, a combined review should be carried out maybe annually, maybe biannually, by the specific discipline supervisors, and all their knowledge should be shared evenly throughout the facility. It was observed that some supervisors fail to attend the planning maintenance meeting. That is again to do with the culture. That some of the supervisors they can just say, "Oh, I know what I need to do. Just send me the document." So that is also not very helpful because they were not providing any feedback back to the planning department. Uh, this was one of the observation made by one of our maintenance experts that the task list or the checklist they were using were quite outdated. So it was recommended that MOC cycle should be carried out first of all to remove the duplicates. And the second thing is to update the job plans or the staff procedures as we call them now to state of the art, suit with state of the art technology, state of the art techniques. Predictive should be more used, more facilitated as compared to predictive or proactive use should be more.
Which
Right.
are a bit unclear towards the end of your sentences. It's a bit unable to hear you clearly.
Sorry. Can you hear me now, sir?
Yes, it's fine, but then towards the end of the sentence, it kind of just dies down. I don't know what
Okay.
happened.
I'll try to.
Okay.
Right. Basically, what I was trying to explain was that from our RCM team, there was one observation made that the task list that the maintenance team was performing was quite outdated. The techniques they were using were not state of the art. For that purpose, recommendation was made that management of change should be performed least like annually by the discipline supervisor. And the expert opinion should be taken to optimize the job plan for the maintenance staff procedures as we call them. Right. The maintenance management system caters for most of the aspects of maintenance performance, but has been observed that the maintenance quality management system was not in place. This was a very critical observation that they had maintenance KPIs, but the performance KPIs or the rework KPIs were not being monitored. If somebody is performing a task on routine basis, there should be a criteria of how good he should be performing it. Because if the rework is increasing, having a good wrench time is not going to help you. Wrench time is not a criteria for quality. So ensure that you have a good wrench time. You need to have a good quality plan in place as well. A rework is basically waste of resources and a waste of time. Then it was observed that corrective orders were raised for any malfunctioning equipment without any root cause analysis. This was the problem that we identified for the operation department. I mean, other than the delays that were being faced from operations department, there was also another case that for any minor issue, even if a pressure gauge they believed it was not functioning properly, they were logging it as a corrective order. See, Nowadays, as a part of maintenance optimization plan, the orders are always prioritized based on the criticality. The operation department could not be the sole responsible on defining what kind of criticality a particular equipment holds or what kind of criticality a particular failure holds. This has to be handled by a system reliability department, where a root cause should be performed, what kind of failure we are talking about, whether it is critical, does it actually affect the system. For this purpose, we perform something called RCM and RAM analysis nowadays. Both of them are for this specific purpose, so you can prioritize your maintenance activities in a better way and a more efficient way. Okay, work management procedure. It was observed that the maintenance policies are in line with the maintenance backlog for both preventive and preventive maintenance order. That is about the backlog. During the site collection, it was observed that the maintenance technicians are also supporting the ongoing project activities. Yes. Now, in this case, what they were doing was that this practice is generally common for all the oil and gas operators or all the energy operators nowadays, that the maintenance team has to support the ongoing project team, because most of the companies are not keeping the two independent teams anymore. However, during this course, has to be a check and balance that if a certain skilled technician is assigned to a project, then he should not be evaluated under maintenance. This is where we actually made a proper observation on certain skilled staff, that if they're assigned to a project or a shutdown, then why are they contributing to routine maintenance? This was supposed to be looked after by the maintenance supervisor, because if, let's say, 100 hours have been scheduled by the scheduler, those 100 hours, if they are being spread among four people, you will not actually be able to perform the job within the scheduled time or within the scheduled resource. Then there were some observations that were specific to each category that we have just discussed. I won't go into much of the detail, but just like we discussed, that the work assignment was one of the biggest contributors. There were certain observations made about it. The permit delay was another big contributor to the gaps. There was some observation made how to improve this one. Travel category, waiting for instruction category, so on and so forth. Each and every category was in detailed analyzed, and then in detailed observations and recommendations were made for, like, waiting for material, wait for optimization should be done. Uh, Instruction, there was an obsoleteness study recommendation that was made for this particular case. There was permit delay for this part. Okay, just like any other study, this study there are some certain suitable assumptions that need to be made as well. Because all qualitative studies or semi-qualitative studies, there are certain assumptions that we have to make, because not every situation can be explained in black and white. It cannot be highlighted with the same marker. Explanation of instruction is a very vague area. It needs to be classified properly. Break time, again, if it is overlapping with personal work, it is recommended to be observed separately. And same is the case with work assignment. Work assignment cannot be done during a break time. This was one of the observations that we made. The supervisors on the tea table were generally saying, okay, you do this, you do this, you do this. That's not how it should be done, because that not only confuses your skilled staff, it also creates a havoc for the schedulers, that nobody knows who got assigned with what. In most cases, the work completion was identified permit closure, although in some incidences it is also observed that the task performed as per the task list was not yet completed while it was being reported that it is closed. So this is where the supervisor has to play his role, because the next time observer can only make a suitable assumption based on the system itself, cannot make an assumption or cannot have a stance on when a task is complete. Since it is practically impossible to schedule the crew members, just like I explained, that we defined a 5-minute round of period. Uh, in- then we have a Velosi actually had a complete methodology for this. More or less what we have already discussed the methodology also covered a lot of other factors that contribute towards maintenance, not just the MTTR optimization, but other maintenance aspects, system aspects that are also covered as a part of it. End of the day, each organization is unique. Each organization needs to have its own customized system. You cannot use the same stick for everyone. So each plant, each organization, each setup has to be observed within their own context. So these benchmark values, just like we mentioned before, are in the industry averages, but you have to consider them in light of the observation or the expectations that is right. And it is an extensive process to perform a range time analysis, but if it is done properly, it gives you a good baseline where to improve on or what to improve on in the future. Somebody was asking about benchmark. This is the maintenance excellence institute. So we took the reference from them. It was one of the reference. This is from DNV probably, and they also showed their bench time. They had different benchmark values. One of them was also related to that explored annually. So that is how range time is generally performed. The type of outcomes you can expect from it, what kind of data you would be expecting to get out of it, what kind of observation you will get, what kind of support you will get end of the day from all of this data, where to improve, what to look for, what kind of system, uh, how to identify the problem within the system. This is the main purpose of the that I'd like to hand it back to Sarita.
So, Bujat, so are we done with the presentation now?
Yes, sir.
Okay, so we can go to the Q&A slide. So one question was, the slide with our approach with all the 11 steps. If you can show that slide again and just briefly just give the overview of that.
With this one, sir.
Yeah.
Right. As as I was mentioning during this presentation, that there are two main factors, culture and system. They both need to be evaluated for time analysis. The first three steps are completely associated with the system itself.
Sorry, Bujat, your voice is unclear. Maybe you're speaking away from the mic or something.
Is it any better now?
Yeah, now it's fine, but then later on it just
My
like it's
apologies. Might
unclear.
be something to do with the internet. Just give me 1 second. I'll sort it out. Right. Can you hear me any better?
Yeah, this is better. Yeah.
Okay. Now, uh, range time analysis, just like I mentioned, it depends on two factors, two major factors, culture and the system itself. The first three steps are totally to identify the system, whether the system is in place to support an efficient maintenance system. When you're talking about maintenance optimization, you need to have a base system that needs to be optimized. So the first three steps basically just say whether the maintenance system is in place as it is required, whether the planning is being done, whether the task routines are available for the maintenance craft that needs to be performed, whether or not the bill of material or the spare parts have been identified, the min max are identified in the system. Then the next three steps are actually categorization of data that needs to be captured. Sorry, next four steps are categorization of the data that will be captured during the range time analysis. First one will be the category definitions, like what kind of work the people are performing. You will divide it or decide it into certain categories. The second one will be the manpower coding. The purpose of manpower coding, as I earlier explained, is because to ensure that the data captured is correct and can be re-verified at a later stage. The next step would be the work order selection. This is to ensure that all kind of maintenance works are captured within the analysis. A certain category is not highlighted more than it is required. Then the last step or the seventh step was actual capturing of the data. of data or the field observation as we call them. So these four are data capturing steps. Then once you have the data, there are some sample calculation method, statistical calculation, general statistical calculation. We group the data together. Right, let me see if I can share.
All right. Okay. So now we'll just address the remaining Q&A. So how do we minimize the backlogs?
Backlog is not to do with range time. Backlog is a part of planning system.
Okay. Now we mentioned travel here in our
Yep.
presentation. What do we mean by travel exactly here?
See, when a certain maintenance task has to be performed in field, you have to take your personnel there, you have to take your tools there. If spares are required at site, you have to take those spares there. All of that is counted as a travel time.
Okay. Um, and then somebody's asking, what is the best PM or CM ratio?
Again, there are generic benchmarks available. People say 2080. Nowadays, now we are talking about predictive maintenance. So the CM should be 5, 15 should be preventive, and the rest of the 80 should be predictive. So over a period of time, the reliability criteria or the benchmarks are improving slowly, slowly. With the predictive techniques, the previous 2080 ratio is no longer valid. So nowadays, we are talking about it should be 5% corrective, 15% preventive, and then everything should be based on predictive techniques or the proactive maintenance.
Okay. Next question. So what is a discovery job and how is it different from CM?
A discovery job is again a maintenance, you can say, it's a maintenance terminology, nothing to do with range time. But a discovery job is basically during a breakdown maintenance, you or during a preventive maintenance, you find out that you actually have to go for a breakdown maintenance as well. An example could be you are performing an annual inspection or a re-lubrication of motor bearing, and you suddenly figure out that from the vibration value or something, you figure out that the bearing is actually gone. That is a discovery job. That will actually convert into a corrective maintenance job. Now, that will depend on the criticality of the equipment itself, whether it is a high criticality job or not. That's like a discovery job.
All right. Next question. How many people did we use to conduct all these steps?
But it depends. Uh, it depends how in-depth analysis I'll be looking for. For example, if I refer back to the plots, you can see that we actually kept 69,000 minutes in total. And for this particular job, it was about 7 people deployed, 7 observers deployed solely for this thing, and then there was some data analysis, etc. So it depends how in depth you want the analysis to be, how accurate you want it to be, how what is the total plant that needs to be covered. You can perform the same thing over a longer period of time with less manpower as well. But it depends. It depends from plant to plant. What are the requirements?
So, okay, next question. So the range time that we calculated for this plant, so like what does it tell us about this plant? Like what's the conclusion? I think we already covered that. If we can just repeat that bit.
Well, in a very, very layman term, I would just say that it shows that this plant is working under a reactive program. As per the industrial benchmarks, a reactive plan or a reactive maintenance program will end up with a 3% lifespan. This is what this product.
Sorry, can you repeat that?
Well, I just said that from the data that we have here, it just shows, as per the industrial benchmarks, that this particular plant was running under a reactive maintenance program, where the 33% bench time means that a lot of bench time improvement is required to be performed. Because the industrial benchmark is 30-35% means they are under reactive maintenance. They are not proactive or predictive.
Got it. Okay, thank you. Will the range time reduce the need for maintenance?
See, sir, in the beginning, Sir Jas actually explained it quite well. Bench time has to do with optimization of your mean time to repair, MTTR. need for maintenance is your mean time between failure, the reliability of your equipment, the quality of the work that has been done. That is not ensured by the red flag. This is one of the clear clauses that Sarjas actually explicitly defined that the quality of work is not covered under red side. It has to be covered by the maintenance supervision.
Okay. Um, Now, this approach that we carried out, right, is it also applicable to any other oil and gas? And is it also applicable to any other industry other than oil and gas?
Yes, definitely. Actually, this time motion studies, they were started for production plants. Later on, they developed into Six Sigma, etc., different techniques, but they were actually implemented for production plants. Then later on, they were implemented to maintenance. It can, the theory or the concept itself can be implemented to anything. In fact, I think in the beginning of the presentation, if anybody noticed, there was Kaizen mentioned there, which is a lean production technique, nothing to do with maintenance. But the theory or the concept can be applied to runtime as well.
Got it. Okay. Next question. Uh, did we carry out a secondary survey once the company implemented all the recommendations?
In this particular case, not yet. However, the first case is always your baseline. So after 1 year, you have to reperform the study and you have to see if there is any improvement or what are the new factors that are emerging.
All right. Now, to optimize his range time, will this lead to more increase in manpower?
Not necessarily, but it will highlight the problems that you actually have in your system. Because if you are having generally increase in manpower is not a result of bench time. The decrease might be depending on the findings, but increase not. Because if you're having a range time of more than 60% and still you have a backlog, that's where you're looking to increase the manpower. Right now, if you're standing at 30% or between 30 to 35%, that is not a shortage of manpower that you're facing, it is a shortage of the system that you're facing.
All right, next question. So, what kind of losses did we observe in the permit to work system, and what improvements were suggested in this PTW system to ensure the safety of the activity?
And we go back to the observation. Basically, the general observation was that for permit itself, they had two system in place. Just like the approval system, they had two different permit systems in place. At the same time, the culture itself was not very friendly from the coordination between operation and the maintenance department itself. And then, if you need a permit for from a different department within the maintenance, there was a certain delay. I mean, one major gap was if mechanical wants to isolate a system, then they have to wait for electrical. And electrical did not have that particular isolation in their schedule, so it was plugged in as an emergency work. So they will come when they are available. So there were multiple factors like this that were identified during this study that it needs to be streamlined or optimized. End of the day, they all fall back to proper scheduling and planning, no wonder. But there are multiple factors that were.
Okay. Next question. Were we able to measure the impact of the wrench time on the MTTR?
He said that for that you have to perform the second evaluation after the implementation of recommendation, and that stage has not yet come for this particular question. Because the first one is baseline. That's where you identify the gaps. Once you have implemented the recommendation, then you go for the second.
All right. Next question. As per industrial working norms, it's advised that you have to take 5-minute breaks after every 50 to 55 minutes, consistent sitting. Does that also affect the wrench time?
No, if it is a planned break, then it should not see. We'll go back to it. That is again. Kindly let me know when everybody can see there's a certain Excel
Yeah,
plot
I can
that
see
has
it.
see, if it is a scheduled break, that is not a problem. The problem was what was associated with the scheduled break within the same time frame. So the flexi breaks, they are not a bad thing if they are conducted as the system designs it to be. But if you're performing it willy-nilly whenever you want, for example, if somebody is taking a personal break at 8 o'clock in the morning and calling it a 5-minute break, that's not going to contribute well towards the rest time. Similarly, end of the day, we have 285 minutes of breaks. That's not what is actually required.
All right. Next question. Is there any correlation between the wrench time with the accident severity?
See, accident severity has to be ensured by process safety and the safety department themselves. Bench time, you have to perform the task with the required security measures in place. We are nowhere recommending that the security measures should be bypassed. So, accidents cannot be affected by the wrench time. If you have guidelines and procedures in place with the safety measures, like for example, throughout the day you will see that the security clearance or the permit delay is there, but most of the time it is very short, or you can say it is being effectively handled. However, if you see a big chunk of permit delay, that is where the problem is. So nobody is asking to bypass the safety measures, but they should be streamlined, they should be properly organized.
All right. Next question. So, which sector or region is performing well as far as this wrench time is concerned?
So we have only observed a few, so we are mostly concentrated within Gulf. Maybe West is performing better, maybe offshore is performing better, because the data that we have reviewed, it appears that offshore platforms are the ones which are having the best range time data for some reason. Could be because the people are isolated there, they got nothing else to do, and they concentrate on their work. There could be multiple reasons for that.
True. Okay, next question. What's the maximum improvement in wrench time that that one company can reach, even if proper planning and scheduling is done?
Sir, it depends. As just what we were discussing before, that industry averages for the top quartile are up to 60, even 70%. And even here, this industry, they're not in a bad shape. The only difference is that they have to cater for the major contributors, which was about 30% of the time that was wasted. They just take care of that one. They were within the same ballpark figure. So most of the industries, they are in good shape, but they have some problems, some major problems that need to be identified through such analysis. If we fix those problems, we can be within the top quartile of 50 plus percentage better.
All right. Now, there's another question on the effect of the plant maintenance hierarchy to achieve maximum productivity.
Plant maintenance hierarchy does come into play when it comes to take a decision. Yes, we have seen that where a plant maintenance system or the plant maintenance is not hindered by other disciplines, or they have their own resources that they can arrange their own, it does improve the factor. But that would be a specific criteria or a specific case. In general situations, in general setup, the plant maintenance department is not generally interlinked so much with other departments. So we have to, I mean, just like we said, that it is a case to case basis. Situation.
All right. Now, during the overhauling of machines, a different problem might arise, which might take more time to address. Then, how could we compare a job with the benchmark?
So, just like we mentioned, bench time does not actually specify to the time that you will take to perform a certain task. When you're talking about overhauling, now you're confusing it with MTTR. Bench time helps to improve the MTTR. It does not strictly, what you can say, guide that this should be MTTR. That has to be done by your maintenance. That has to be done to your maintenance supervisors. If it takes more time to perform a certain overhaul because of the discovery jobs or because of the new corrective work orders like open as child work orders, it will not affect the range time. Yes, you do not have the spare parts available to perform those jobs, or you are unable to schedule those jobs for a certain period of time, then that will affect the range time. Range time is about optimizing the utilization of manpower, not to do with the time it will take, the actual time it will take to perform the job.
Okay. Next question is on the software. I think we use Maximo here for the CMS. Is there any recommendation?
CMS, no sir. See, CMS system, every company has to decide for themselves. There are many industrial softwares available. For example, we have a complete in-house solution in form of Whale Plant that can take care of CMS. We have our RCM module, we have RBI module. Similarly, all the CMS developers, they have modules like this. So we cannot say one is good, the other one is bad. Yes, with time, you will find out that the newer ones are well with the new developing technology. That's it.
All right. Um, so have we linked this data analysis with different cultures and wages? I think so.
Cultures do affect it, but I don't understand why the wage would affect, wrench time. I mean, a low paid worker is still being paid to perform the same job. Yes, the condition in which he is being asked to work, that might have a difference, so which will again come back to the system issue.
All right. Um, yeah, many people are asking about how much time it will take to execute the study, and then how much time will the client take to, improve the wrench time. So I guess it just depends on the scope of work and the
That is correct.
operations, and yeah.
That is the
Um,
size of the facility, the size of the maintenance department, how much operations are running in parallel, all of that makes difference. Like the one that you can see here, the example that we are quoting here, they had more than, I believe, I have the figure here. No, but this plant had more than 21 different sections or plants running in parallel. So it depends. This one we took about 8 weeks to complete the whole complete data observation.
okay, there's also another question on, sort of when you're recording the time that's taken observing a technician, right? That can also have an impact on the way the technician executes his or her task. So, is there any way that can be avoided, or like what's the industry best practice nowadays to sort of record the time taken for each task?
See, sir, for the range time observation, you're not meant to shadow the person or distract him from his working methodology. This is the first requirement for the observer. He has to understand what is being performed, he has to be non disruptive, and he has to be a silent observer. The first thing the management itself has to ensure to the maintenance team that this bench time is being performed to optimize the system, not to put the blame. These are the first of the few things that Sarijaz explained in a very delicate way. That if your worker is comfortable that whatever being done to help me in future and is not to put a blame on me, he's not going to shy away from work. Yes, when you start the observation, in the first 1 2 days, you will see that the range time might even hit 80, and your observer will be like, maybe I am capturing it wrong. But after the second day, people start to settle down. They get back to their normal routine. That's why you cannot have a range time observation in a short burst of time period. It has to be over a period of time under normal running.
All right then. So I think we've addressed most of the questions. Many of the questions are repeated. So thank you so much, Wajahat, for the presentation, and thank you everybody for attending. We hope that you found this webinar useful, and We also hope to see you in our upcoming webinars in 2 weeks. All right then, everyone have a nice day, and we'll be ending it now. Thank you. Thank you.